Hello everyone, I want to welcome you to another round of Commodore Very Basic. This will be the fourth tutorial. In this series, we're going to be going a little bit more into the book. And as always, this is the book. And sorry for that awkward pause there. My webcam wasn't showing, so I couldn't really see what was going on. So now that I can see the webcam here, this is the book, Commodore 64, C64 Owner's Manual, that we'll be going over as usual. And let's see where we are in the book currently. And I'll go over, we'll do the highlights here in just a minute. I just wanted to show you which chapters, for those who might be curious, like how far we've gotten in the book, if you own the book in general. So we are up to this section currently. It's actually page 53, right here. So right there is where we're at. We're at the page 53, and that's on the chapter for chapter 5, basically, in this book. So programming in basic. So we'll get into more of that stuff, and I'll go over that here in just a minute. And I've got everything, again, organized here so we can go over it step by step. What I want to do also is probably elaborate upon that other menu program, since we'll be doing some more, introducing some newer commands this evening. So let me go over what we previously went, as always, to kind of to stay consistent, letting you know where we've been and where we're going. Okay, so last time we were talking about loops, and we used that and demonstrated that in the program. So this is a loop, another loop, and so on, just to demonstrate the different type of loops. And you just go to the line and it'll execute all the loops, and you get some kind of a weird looking loop there. So that's basically what it's doing. We already talked about this. This just prints line by line. Oh, we forgot to do the semicolon too. I'll just throw that in real quick. You put the semicolon out and it kind of leaves it on the same line, so you'll see it's right on the same line right after this is a loop. So anyways, show why we had some numbers in there. Something got translated into numbers. That's kind of weird. Anyway, I'm not going to dwell on it, but that's kind of strange that these numbers suddenly popped up on the screen when I have nothing in here. So probably I turned this one in. I left out, you want to call it this, but I left out the semicolon here, so I turned this part into a number, actually. So we'll go back and fix that. That was actually interesting to learn about that. And just put it back, and the numbers will be gone now. See? Okay. So let's begin anew here in just a minute. We also talked about conditions. So if we have like the variables, we talked about variables. Of course, if we have like a simple variable, and you don't have to use two variables. You can just use, two characters for a variable. You can also use one character. Commodore will still accept that. It's just if you go beyond 2, it ignores everything after the second one. Okay, so we'll just set this to a value like 25, for example, and then we'll say if 5x times, let's just say divided by 25 is equal to, so 25 divided by x, actually let's set another value here, so just a quick demonstration here. So this will be our value, which we'll be talking about inputs here in just a minute. Let's just call this, let's see, let's do, instead of 25, let's just do 32 or something. I think that would be better. So we just say if x divided by 4 is equal to 8, then print the result is true. Otherwise, it won't print anything. So we're just basically saying if 32 divided by 4 is equal to 8, then the result is true. So it should say the result is true, because x and v is 32, and 32 divided by 4 is 8. So hopefully that makes sense. That's for the equals. Now, if you wanted to say greater, you'd have to throw in another line and say something like, we're going to lose our line 4 here or something. If x is greater than 30, then print above 30. 30, I just leave it like 30, you put a little thing after it. And now, since x is greater than 30, it'll print above 30 right after the result is true. And we could also use the second value if v is less than, I forgot where this is all at again. So using the Commodore keyboard, again, you have to kind of convert characters over. And by golly, I don't have my little key thing with me right now, so I can't remember this down here. Actually, it's same on the PC keyboard. So if v is less than 5, then print v is equal to 4. So just simple examples there. So it says v is equal to 4 because v is 4. And the value here says if v is less than 5, which it is, the -1 represents true, by the way. That means it's true. But if you say v is greater than 5, it'll show a 0. That's just another way of the computer looking at it for true and false logic. So not to go too far in it, but those are just some of the values. So greater than, you can also have greater or equal to a value. So if v is greater or equal to 4, I know these are bad examples, so excuse me on that. Just trying to think quickly here. Then print the value is either 4 or greater. And you'll see that message on the screen too, because it is. And then finally, 70, I guess we could use the x. If x is less than or equal to 32, then we'll print the value is 32. Let's see, less than or equal. Well, this wouldn't make sense actually, because the value is either 4 or greater. So in this case, it wouldn't be greater. So that's just a bad example there actually. So hopefully that makes sense, and we could probably just ignore those bad examples. I just wanted to show you those are the greater than and less than. And you've seen here how you can kind of use the values with, you know, together to get a result. So this is used very commonly in the world of programming. And of course we talked about sums too. So if we take the two values, 32, and let's just call it SS for sum. Remember, you can use any variable you want. It defaults to 0. So now we're going to add the sum. So SS equals SS plus, so we're going to add the result to SS. We're going to say X plus, V. So that's going to take 32 plus 4, which is what, 36? Oh, we've got to print it on the screen. So we got the result. So if we print SS, we'll see our result there, but we could also just go down here and print SS for our result, and you'll see 36, or you could even do it like this, just to be fancy. Total sum. I like to do like little semicolons there, and you just put SS after it, and it'll do the same thing. Total sum 36. Like if you have a checking account or something, you want to keep adding to it. You could also, you know, subtract from it. So you could just basically say, I just call it BA for bank or something, equals X minus V. It'll give you the result 32 minus 4. Of course, we got to print it out again. BA. And you'll see it's 28. So basically all it's doing is just doing math. So BA is X minus V. And I'll print out X comma V so you can see them. So 32 minus 4 is 28. So hopefully that makes it pretty simple. And you can do a lot of things with the programs by doing this. I mean, if you're into games, which you know I was for a while there, you can make things move on the screen, move left on the screen, determine where they are. You can get scores like calculations and points, like when you have points adding. This is great for when you're having points added. Of course, if you wanted to, you know, make it even more fancier, you could just like multiply it by something. Let's say if you got like 100 points or something. Where is that key at? I'm trying to find the asterisk. Let's say you can multiply it by 100, and then you'll get a totally different result. 432. And watch this trick. We learned about go to earlier, so I'm going to show you something else here. So I'm going to go to line 70, and you're going to see a lot of different results here coming up. Watch, this number is going to keep growing, because this is basically adding 100 plus these calculations each time, so you can kind of see it growing down the screen there. It's a good way to get a scorekeeper going on. So hopefully that makes sense. And now I'm going to introduce the next chapters. Some of this stuff is more if you have a Commodore 64, so we're not going to demonstrate it, but it talks about formatting a disk here. So we'll erase our program. We're not going to need it for anything. It's very simple. So formatting a disk, I'll just put this remark, by the way, is comments if you haven't caught on to that. I know I didn't really explain that very well earlier, but is it 2 T's? I don't know. Formatting a disk. And if you want to format, you use the open 15, 8, 15. And then on the next line or semicolon after it, you just hit print number 15, N. In this book example, they have this. And they have a string, which is probably, yeah, we introduced strings already, so it's safe to show those. I won't do it here because I don't want to format my disk, but if I run this, it would actually format a disk here. But I don't want to just, erase what I already have here. I could do a simple example like save this and probably erase it or something like that. Let's see if we could actually do that. Just to kind of take a left field here for a minute. So I'm going to basically go up here to Vice, and I'm going to create a new image to drive 8. Drive 8 is just for the disk drive. And then down here you can create whatever you want to call the disk image. Like I think mine might be down here. Like I have raster, this one, I have this one. So we're going to go and create a different one here. And we'll just call it Vice Test or something like that. It doesn't matter what you call it. Just as long as you have some kind of a name for it. And up here's the file name. This is the name of what it's going to show on the actual, like here, the name of the actual directory. And we'll just say erase disk or something. It doesn't really matter at this point because we're going to just demonstrate erasing this, and then we're going to go ahead and create the image here. And if you look down here, see, where did it go? Did I create it? I know I created it somewhere. Maybe I created it inside another directory. I don't know what I just did there. Let me just go up here for a second. That's really strange. Not create image. Let's try this again. I don't know where it went to. Device test. Create image. It might be creating them. I just might have to go backward and forward. I don't know really strangely where they're at. Okay, there it is. So it's actually created, what did it do here? Created this. And some really weird stuff here. We could use any one of these. I don't know why it's doing all this, but we could use this one as an example and just erase this one because I don't think there's really anything in here important. So let's just use this. So we're basically going to select that directory, which is what the D64 is, that directory there. And we're going to attach it so that now anything we do in there is going to be saved to that. And we could just save format disk, 8. And that's the save command, which I know I just jumped ahead, but I had to use that to save it to work. But in the book, they actually show you format first, and then they show you the save program. But in this case, we have to work differently because we're working with Vice. And let's go ahead and go back to here. All you have to do is hit File again, attach disk, drive 8, and you just look for it. You have to click on it here to see it. And you'll see right there it says format disk. That's the one we just created. And since it's very simple, we'll go ahead and run it. And I think it will erase this, but let's see what happens here. I'm curious. I've never seen this done. Oh, I got an error message here. I didn't even realize I had an error message there. Okay. Why did I put a number 15? Oh, I know what I did. I left out the string thing, the quote. You got to have the quote after it. It won't know what you're formatting there. And you can close it like that too. Now it should work. Or not. What did it do to my code here? Oh, I didn't put that was my fault. Not used to this keyboard. I hit shift instead of just hitting I hit the calling instead of just hitting the shift key to kind of get to it there, so you don't have to hit it. I was hitting shift and getting that. So, but I'm still getting an error message. Why? That's exactly what the book shows. I take a pause here for a minute. Okay, so it's right here. It's on page 47. That's where we're at right now. And I don't know, I got to copy it exactly how they show it. And we're still getting an error message for whatever weird reason that is. Let's try this. Let's see if it did erase it out of curiosity. Probably didn't, but I'm just going to check it anyway. Still there. Did not erase it. So I just renewed the program and I reran it here so we could kind of type it in again. For some reason it doesn't like what I'm doing. And I just spent a lot of time on it. We're not here to teach you how to format a disk, but that's how you would do it according to the book here on the Commodore 64. We learned about the save command, so I'm going to skip that part. That was actually next, which is basically just save. And then you just put the character name in. You can use up to 16 characters for this name. So it could just say format diskette. And you just count them. You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I could probably add another value. So I'm going to add 64 at the end to see if it, truncates the 4 there. Because it says it can use up to 16 characters for the name. Let's see what it did here. Yep. So right here, if you look, it actually truncated the 4 because it can only hold 16 characters. So also, to show you another trick here, I'm going to new this so we don't have anything in memory. Now I want to show you another way you can open it. You don't have to always load it directly like that. You can just go right inside the disk image once you have one, and you can just double click on it right here. It'll just run it. It actually runs it and opens it at the same time. I forgot about that. Of course, we got that error message for some reason, which I'm not going to spend a lot of time here. But if you want to throw it in the comments, once you figure it out what it is, that's totally fine with me. We'll move on. Now we're going to go ahead and we're going to replace this, and I'll show you how to do a replace. So you want to overwrite your file. So you've already been working on, let's say you've been working on code for a good while. Where's that key at? And you don't want to lose your changes. You don't want to create a new directory name or a new file name. You just basically use this little @ sign, which you see Commodore in the worldwide, with emails, and you hit a 0 after it, and then just whatever the original file name is, so you'll want to know what that was. Was it format disk? Format diskette. You just hit 6 and this time, and it'll overwrite that. And if I added anything new to it, it would add it on top of that. So let's just say I went in line and I created another remark here, and maybe it said line 18 says, this will format a disk, even though it doesn't work. And then you see it right there, and then we save replacement, which is next to the P on your keyboard, to know where it's set up as the default on the keyboard there. And then we're going to format diskette 6 to replace it. And I'll show you when we run it, it'll still have the same changes. Because if you try to save it like this, for example, it may or may not work here. On the regular Commodore, it won't work. It'll give you an error message and it'll flash the drive. Here, I just don't think it'll save it. It may still work here. I don't know, but I just wanted to demonstrate that. So now we have nothing in memory, and we're going to go back to the directory again with our attached disk image under the file menu. And here it is, and you see a diskette, and I open it up there. It's going to run it, of course, and you just saw it. It included the new changes we made to the program. So now we can erase it. Alright, so you can also use this called Purify command. I think this was popular in the Commodore 64 because some of the drives in those days would fail, and they used Verify to make sure a file was saved, especially if you've been working on a program back in those days for hours. I can give you an example. One time I was working on an Atari computer, which I started on Atari, and I sat there, and I wasn't the greatest typist. I spent, I think it was 4 hours typing in a huge listing, and what never occurred to me as there was parts of the program that was going to be erased by code that was already meant to erase parts of the program. So in essence, there was commands built in to erase certain lines, and when I went to run it, I noticed some of the lines were missing instantly, and I thought I had lost my changes. Now the Verify command would let us know if we had saved that and left it in memory, whether it was on the diskette. That's probably a bad example, but anyways, the whole point of it is you save, like let's say I type in a program and I saved it, and I thought it was saved, and then I just went back here and I just, whoops, I just typed in new here, and then I tried to reload whatever that program name was, and it wouldn't load. This is just going to throw me an error message. It would just sit there and say file not found or syntax error or whatever it says on the target there, and give me an error message. And then with that error message, I know that my program is gone forever. So my 4 hours of work is gone. So Verify was good. It's good for the actual Commodore programs, because if you sit there and we type in format diskette here, and let's say this was a massive program, 6, so let me forget the 6 again, and you just do it like that with a comma 8, it'll say OK if it's already, oh, they gave me a Verify error. Oh, usually I get an OK here. Let's see if it lost it here. Maybe our format command worked, who knows. It's supposed to say OK anyway. I've been doing a lot of crazy stuff with this. So, format diskette 6, maybe I spelled it wrong. Let's see. Format diskette 6, I don't know. But anyways, that's the whole purpose. I'm not going to spend a lot of time on Verify, but that's what Verify does. And if you want to delete a program, we'll go in and we'll delete the other program, which I think was just format disk. Yeah, format disk. We'll see if this delete command works. You can just basically type it in like this in its own line. I'm hoping it works. And then whatever the name of the program was, format disk, close 1. So basically it's opening a file here. This is the 1, so it's opening up this file 1. And 8,15 has some, I don't know what these have to do with, but it's something to do with, you know, setting up the file and all that. We'll probably get more into that later. They're not really going in a lot of detail in this book, so I just wanted to see if this is going to erase it or not. Or is it going to give me a crazy error message? It might take a moment. Okay, gave me an OK. Now let's go back to C, and we'll just do it here just to make sure, and see if it's gone now from that directory. Hopefully it is. It is. So look at that, it's gone. So it actually worked. It deleted that file name directly for us. Awesome. And then we got to initialize a disk drive. I'll show you this one. I'm probably going to lose my other changes. We'll see what happens. Not a biggie. I mean, these are already written down on paper. I just want to see what this is going to do. Okay, so let's see what it does. Now, initialize on the Atari computer would actually end up formatting and erasing it. So let's see what this does. I guess it just probably just verifies the drive or something. I don't know. It says that the disk drive's red light is flashing. There's a disk error. So I think it basically is a good way to make sure that you have a valid floppy disk in your drive and so forth. Okay, I'm back. I paused here just for a minute just to show you that this is an actual floppy disk here. So this is what it means by initializing a disk. You just want to demonstrate there. So if in those days, like for example, if you put the disk in a drive and you use this command, like say if I'm not mistaken, it verifies that the disk is good. And if it's not, then I think you're supposed to get an error message or something. But anyways, what happened earlier when we did this? Let's run this again. I don't know if it did anything. It just says ready. Okay, we're not going to spend a lot of time. I want to get to the good stuff. We're getting so much stuck on this. But we have to get through the little stuff to get to the good stuff. Okay, so now we're going to learn about a more simple and controlled way of looping. We learned about our famous goto and all that stuff earlier. Now we're going to learn about, introduce something new called for next. And I'll demonstrate. I'll type in a program that they have here. And before we run it, I'll explain it. Okay, I'm also going to put in my little fancy clear screen. Oops. $147 per clear screen. So when we run it, it'll basically move the cursor all the way to the top of the screen here, since it'll go home and clear. I'll erase everything, all the text on the screen. So let's look at it line by line here. So for next. So for is always going to keep track of what next is doing. So what is for doing? It's basically moving through a series of values in basically the variables. If you remember earlier when I showed you the XX or whatever it was, SS equals SS plus a value like that, plus 1, you're going to see each time I go here, I get rid of these error messages, each time I run this, the value is going to increase each time I go back here and go back over it, and there's just an arrow keys to move up and down there. You see it increasing, and we'll just take it to 5, which is what this example does. It starts at 0, so what it's doing is it's starting at 0. Instead of using SS, this is basically saying this. I equals I plus 1. So if we run this, you'll see, I'm just going to erase these just for example, it'll do the same thing. It's just going to start. Now, you won't see I at 0 first unless I print it out, but the default, remember, is 0. But it's going to show, what I do, I forgot to print the I. To show you, it's already 2 because we can initialize it back to 0. Let's do that first, actually. Probably a better way of explaining this to people. So we can just kind of use this as a test program, like that. So we can always set it back here to 0, so it'll always do like a reset for us. So we got 1, go back and do it again, 2, 3, 4, 5. That's exactly what this line is doing here, except it's a way of doing it without having to capture what the I is doing with greater, less than, or whatever. It does it all itself. It's a condition in 1. So, well, not actually a condition, it's a condition equal to a value. So basically it's just saying I equals 0, then the first time it's going to be equal to 0, it's going to print this line on the screen, and it's going to hit next. What next is going to do is going to check to see if I has reached its limit. So in this point, it's saying is I, and I'll just put it down here, if I is greater or equal, I think that might be it, to 5, then it's basically going to end at that point. So what it's doing here is going to say 0 the first time, then it's going to go to next. It's going to say it's not yet equal to 5, or whatever our range is right here. This number determines our range. So we need to go back to the next 4, or the last 4. So it's always going to keep track of that last 4 next. And then now it's going to say I is not 0 now. It's now increased because next has already done one of these I equals I plus 1 that you just saw me do earlier. And now the value of I is equal to 1. So this time it's going to print our line again. It's going to print. So it's printing Commodore 64 is awesome once, twice. So it's already printed it twice. Next, it's going to do the same instructions. Is I yet equal to 5? No. We're going to go back and we're going to do it again. This time we're going to be equal to 2. And so it's basically taken 0, 1, and 2. So now the message shows up 3 times on the screen. And then it's going to do the same thing for 4. Is I equal to 5? No. So it's still 4 now. So now we're going to go back and we're going to print the message for 4. So it's going to say Commodore 64 equals, it's going to show it on there 5 times, excuse me. So it's going to be 0, 1, 2, 3, 4. And then it's finally going to go here, back, hit the next again, and go back up to the 4 again to obey and be obedient to it. And say, is I equal to 5? Yes. Now it doesn't stop when it's equal to 5. It still has to complete this next to finish that loop. So what it's going to do is going to print the message one more time, and then finally it's going to hit the next, and we know that I is now equal to 5, or equal to whatever this value is right here, so it's done. So it's going to print, it should print Commodore 64 on the screen 6 times, counting to 0. Let's see if it works. It's going to clear the screen, of course. We'll count it. So 0, 1, 2, 3, 4, 5. So it's basically 0, 1, 2, 3, 4, 5. And if you count them, you got 1, 2, 3, 4, 5, 6. Or 6 values if you don't start at 0. But the loops, the variables always start at 0, so it's the easiest way to do it anyway. Okay, I wrote a pretty long spiel on that, but I think I kind of covered all of that really well. Now we're going to learn how, let's have some a little bit more fun with this. Now earlier we said if we change this value here, it's going to go up to that loop. So this time it's going to say, is I equal to, let's say once it gets to 5 or 6, it's going to say I equals 0 to 15. Okay, is I equal to 6? Yes, then we're going to print that line. Next, we're not going to end there. We're going to go back and continue to whatever this value is. So it's going to go, is I equal to 7? Yes. Is I equal 8? Yes. Is I equal to 9? Yes. Is I equal to 10? Yes. Is I equal to 11? Yes. Is I equal to 12? Yes. Is I equal to 13? Yes. Is I equal to 14? Yes. Is I equal to 15? Yes. So it's going to print it 16 times on the screen. Watch. See, it basically just increased the number of times it shows up on the screen. So this is a good way to do what's called a controlled loop. Instead of sitting there saying go to, because if we just did go to, we already know it's just going to keep printing forever. And sometimes we don't want to print forever. I mean, more often, logically, you want to print a series of lines and kind of stop there, which is common if you're drawing something on the screen. Let's say you wanted to draw down a certain number of lines. You would just basically use that loop, and you could use it for drawing. You could use it to draw art on the screen. For loops are the most incredible. I think they're probably, in my opinion, next to variables themselves, they're one of the most valuable things you can learn in development because they can allow you to do many things. You could use a for loop to go through a directory. You could use a for loop to go through just many things. You could use it to basically run through web controls. There's so many things. You could use it to run through arrays, which we haven't gone over, of course, yet. But there's just so many great things you can do with for. I think for is, like I said, in my opinion, one of the most awesome commands that they ever invented. Okay, so next we're going to use for, but we're going to reverse it. We're going to make it print backward. Now this example isn't a good one because we don't want, it's not going to do anything. If we set the value backward, it's not going to do anything in ordinary. And I'll demonstrate it for you just to show you. 15, you start with the last value because backward means we're going to start with the highest number first. 2, 0, and then use something called step. Basically it's stepping in increments, and we'll say -1. And we run it, it should do the same thing, and it does, but I'll demonstrate what's going on here. Over here I'm going to print the value just to show you what I is doing. I just put a comma after it, and this isn't a book, this is just my own example, and you'll see the values are on the screen. 15, 14, 13, 12, 11, 10, 9, and so on. Likewise, if we did it the same way with just our regular loop, it would do the exact same thing. This time it would put it in order. So hopefully that makes sense to you. And we'll also teach you about incrementing the loop. So I can also do it here with the positive value. So I could just say step 2 or something like that. And what it's actually going to do in this case, now if you can guess what it's going to do, you're pretty good. I already can tell you what it's going to do. It's just going to cut the amount of Commodore 64 is awesome in half. So you're not going to see 15 lines. You're going to see a lot fewer. So whatever, you know, the 15 divided by, you know, whatever 15 divided by 2 is, like 7.5. So see, it basically cut it in half because we're stepping through at 2. So we're multiplying by series of 2s. 2, 0, 2, 4, 6, 8, 10, 12, 14, and so on. And you can continue to increase that step, and you'll see it take giant leaps here. It's only going to do a few times there. 0, 5, 10, 15. Of course, likewise, if we increase this number here, we would see more from the 5. So basically, it's just jumping in steps. And if we do it backward, of course, we could do that too. You got to put the negative after 5 because it's going backward. Remember, always start with the bigger number first with the for loop. And there we go, 30, 25, 20, 15, 10, 5, 0. And just remember earlier, this is basically going to start the value of the for loop at 30 and print the message. And it's going to say, is I equal to 30? Yes. Then we're going to print the message, and we're going to go down here. And now what we're going to do is we're going to take 30. Now I'll show you right here. Print 30 minus 5 to get the next value. So now the next value is 25 instead of 29 because we're incrementing, or we're decrementing, reducing it by 5 each time. And it's going to say, okay, now it's good. Now that we know 30 minus 5 is 25, we know I is now going to be equal to 25. So it's going to say, is I equal to 25? Yes. Then we're going to go print. Commodore 64 is awesome on the screen, and of course, I forgot to mention we're going to print our value over here since we added that. Next, And then it's going to do the next thing. It's going to take that value, 25, and subtract it from 5. Now it's 20, as we can see up here on the screen also. And now it's going to say I is equal to 20. Yes, print the message. And it's going to print the number again with our I over here, of course, after our comma. And then it's going to end right there. And now we're going to take the 20 minus the 5. It's 15. So now it's going to say I is equal to 15 because we subtracted 15 from the last value known in memory. And is I equal to 15? Yes. Then we're going to print the message and print our next statement. And once again, we're going to subtract from 5 again, 10, as we already see up here, 10. So it's going to go back, hit the next, go back up to the I again. Now, is I equal to 10? Yes. We're going to print the value. Commodore 64 is awesome with our number after it. Next, hit the value, and then we're going to take our 10, and we're going to subtract 5 from it. And it embeds the number if you don't erase the other number, by the way. You have to erase it afterward. For some reason, Commodore 64 never erases the value next to it. And now it's 5. So we're at the next, and we go back to our 4 to continue in the loop because we haven't ended yet. So is I equal to 5? Yes. Print the message. Commodore 64 is awesome. Comma I value with the value after it. Hit our next, and then now we're going to subtract 5 from 5. Now it's 0. Let's go up here and say, is I equal to 0? Yes. Print our message with the value after it. Next. Now, what we have to do is we've already printed the value of 0 on the screen, so we're done. Because we're not going to go below 0 because we're going to 30 to 0 step negative 5. Now, if you change this 0, you can go below 0, and we'll try that in a minute just to see if it works. Imagine it would. I've never done it this way before, but I never had a reason to. But let's see what happens if we do this. I'm just curious. Might give me an error message, or it might work. Let's see. Actually, it's smart. It knows. So basically, it's now able to do values below 0. And we know below 0 works because you can have a negative bank account. You can have 0. You can have weather below 0, so on. A lot of good examples with negative 0. So without negatives, our world wouldn't exist. It wouldn't function very well. We'd probably just have summer all the time, and we'd have positive bank accounts, which would be a good thing. But then, of course, there would be no reason for business at that point. Alright, now we've learned about the 4 and doing lots of different things. Experiment and play with your own little things on it. I'm going to introduce input. I'm running out of time here. I don't like to make these videos super long, but I wanted to use the input. So now we're going to use and cast input into this simple little program, and we're going to change the result. And I'm just going to set this I back to a regular simple loop so we don't make it too complex for people. We'll set it back to let's just make it 0 to 10. I think that's good. And I'm just going to leave that in, but I'm going to show you the input statement. I'm just going to add a new line for 8 and introduce a new command. It's called input, I-N-P-U-T. And what we're going to do is we're going to input in the numerical values that we can throw into our for loop. Now, this is not demonstrated in the book, but I like to try to twist things up a little bit just to kind of keep you going and keep those people who want to be challenged, and also teach you new concepts. It's probably introduced somewhere else, but like I said, I do my own little flips here and there. So we're going to say input V for a value, and it's going to be asking a number. And once we run this, what it's going to do is it's going to show a question mark on the screen, and it's not going to continue this line until we type something in that question mark, and then we enter, press the enter key or the return key on the Commodore 64 keyboard. And then after that, it's going to print our, it's going to go right into the I loop. So what we're going to do is we're going to control how many times we want to print the message Commodore 64 is awesome on the screen by whatever number we type in. And I'll explain it, but I'll demonstrate it first. See the question mark? Now it's waiting for a value. Now if we hit something like 0, I think it'll just end. Yeah, it's going to print it one time because 0 is part of the loop. So let's just go ahead and put like a different number we haven't used before. Let's just say 50, for example. Now it's going to print it 50 times on the screen, and it's going to end. Just look at our example. It's clearing the screen. It's asking for V. So let's go ahead and print V on the screen here just so you can see what happened. So V is equal to 50. Remember earlier we typed in 50. So what it's doing now is it just controlled 50. It took the value of V and set it equal to 50. This is why when I print V, 50 is now coming up on the screen. So input is a way of creating a variable real time. So what it's doing is it's taking that value of V and it's going to cast it or put it inside of our for loop so we can do a more controlled for loop in a better way even. And this is really a great example when you want to set dimensions and just do a lot of different stuff to control values. You want to, like on the menu example I used earlier, you could sit there and say the cost equals this, input this cost versus this cost, and so on. A calculator, there's a lot of things you can do with it. So whatever value we put in that v is going to be equal to the value. In this case, it's 50. Then it's going to print our message just like the usual. Comma 64 is awesome with the comma I after it, which is going to print our value on the screen. And next, continue doing this until v is equal to the value we put in here. So I'm sorry, till I is equal to that value. So if I is equal to 0, yes. I equals 1, yes. All the way up to 50. I is equal to 50, yes. Print the message and then end after that. So we'll try a different one here. And 15. So I'll print 15 times. So whatever you type in this, you can use this if you want for your own examples. It's going to type that right after and keep track of what you typed in that input statement. So input's a pretty cool thing. You can also use it to print your name on the screen. I'll demonstrate that here real quickly. So we'll kind of modify the program a little bit here. My name is, and we're going to change our input statement. So I'll probably stepping ahead here with the inputs because I don't know if they talk about strings here. Actually, they do in the next example, so I'm right on track. Cool. So we're going to print, and remember, if we want to do a string, we have to change use a letter, and we have to put the $sign after it to represent the string. In this case, we could just name for like names, NM for names, short for names. And then it's going to say my name is, and it's going to remember whatever you type in there. So whatever you have after, it's going to print that many times your name on the screen with the value after it. So whatever number we put, 10. So if you put 10, it's going to call yourself 10. So put your name in here instead of a number. Oh, wait. Oh. I know what I did. This is probably a little bit too advanced. So what I have to do is I'd have to introduce another, and I know why I didn't do it here. I'd have to introduce a val statement to do this. So we're going to throw out the for loop because I don't want to go into val because we're not talking about val yet. But it's a way of converting a number into a string. So we'll erase our for loop since we're pretty familiar with it. We'll just print one simple message on the screen. And wait a minute. Wait. I think I see what I did. Let's see if this works. Input equals v. We could leave that on the screen. Names or something like that. I think that would still work, but it's probably not going to print it as many times as we want. Yeah, it'll just print it once. What this is basically doing is it's still keeping track of v, and v is equal to that value. We could also do something like this. I think we could do v comma nms. Let's try that. So basically it's going to look for a number first and then a name afterward. Let's see if that works. It did. So now we'll type our name and it should print our name 10 times. There we go. It's a great example. But we lost our nm, so we can put after here comma v, or I, excuse me, and just run it. So first time it's asking for a numeric value, just like we did the for loop earlier. It's at 15, and then it's going to type your name afterward with the value. So there, took your name, transferred it into the, and then it printed it, showed the numbers. Now I'll demonstrate it down here to explain it. So clear the screen. So we're basically doing a combined input here. We're taking the value of v, we're assigning it to whatever we type in, the first line. You saw the first question mark. And then after that we hit enter. It doesn't go to the next line because there's a comma after this, which means we're doing 2 inputs back to back. So now it's going to say nm strings. It's going to be looking for a string this time. And it's going to, next after it does that, you hit enter. It's going to go through our for loop like we explained earlier. It's going to print the number of the v, or the value that we put into it. And then after that, it's going to keep track of the for loop. It's going to print our message, my name is, and nms, remember that was whatever you typed after the second question mark, which was our name. And then it's going to show our I, which is part of our counting loop. And it's going to print that, it's going to print your name the number of times that you put into this v every time. It's another way of doing it this way too, but this is just a shortcut way I showed you. You could also do that too to simplify what is going on. Input v, put the value in, hit enter, wait for the string, put the value in, wait, and put the string. Now I want to show you one more thing here. First I'll do it here again and just demonstrate this. That's a better, fancier way of seeing it. Then we don't have the double question mark. And then we're going to print our name. And it does the same thing. I'm going to demonstrate a little error message. So if you throw in your name here, you're going to get redo from start, which the book doesn't talk about. But redo from start is basically saying, I need a number. This doesn't make sense to me. give me a number. So if you keep just typing in anything in here, it's going to keep redo from start. Finally, if you put a value in there, it'll go to the next input statement. Now you can't tell, but it actually went to the next input statement. And then we can type in our name. Now if we do the name and we put that a number, it'll do redo from the start. Oh no, actually it worked because it took your name instead of putting in your name. Whatever you typed in there, it just converted it into a string. So it took 934, converted it into a string. So, well, looks like we didn't get as far as I wanted into in this video, but I come up with my own little spin on things, so I want to always keep them within 45 minutes. And next, we'll probably be talking about the get statement, and we can start adding to that menu program and just doing some more fun stuff with it, and just stop, introduce, and continue and stuff like that. But this is just a short example. Hopefully this will get you started, and now you know how to print your name on the screen. Use some of the earlier examples, the menu and stuff like that, and the conditions and the variables, and see if you can, the coloring and all that. See if you can come up with some pretty cool programs, and let me know if you do. I'd like to see what kind of work you do. Just throw me a comment out and say, hey, I wrote a program. I'd like to see it, because one thing I've still been doing, and I haven't been doing in a while, and I haven't mentioned it, most people may not remember it, I can still take your program examples and stick them on my website to show everybody else, just to kind of keep us all networking together. But anyways, if you like this video, go ahead and please, subscribe to this channel, and I encourage any favorites and thumbs up is a good thing. So, yes, I hope you guys enjoyed this Commodore 64 as much as I enjoyed putting it together for you. Have a good day.